What's up, guys? Yes, we are live, and I don't know if my internet is great this time. So, hello, please tell me in the comments, how are we technically? Can you see me? Can you hear me? Any terrible lag? It seems that we are getting some lag, but hello. Let me try something here. People on Instagram, I have my Instagram there. It's live, but the live is on YouTube, so go there and watch on YouTube. Yeah, video is a little bit crappy. I changed my connection here. Why my video is so laggy today? Okay, video lag, but yeah, we might have to deal with that today, with the video a little bit laggy. I don't know why it's so laggy. My internet usually is pretty good, but today not as good. Let me see if I can do something in my settings here. Yeah, everything is fine. I don't think I can change anything right now. Yeah, but audio is good, right? Video is choppy. It is what it is, but once you see my screen, there's not much motion going on my screen, but as long as you can hear me, I think we'll be good. Not perfect, but live is live. So, okay, guys, welcome, please. Where are you guys from? Where you guys are? Where you guys are? I want to know. Here in Brazil, it's a holiday, so I'm here during the holiday doing this live for you guys and for me too, because I think it's gonna be quite fun. I don't think I can change anything else now. Let's see, stream settings. Yeah, I'm in normal latency. I don't know anything I can. Maybe lower the bit rate. Yeah, let's try lowering the bit rate. Let's try. And I'm not going to change much now because I don't want to risk losing everything. So we have Queens, New York City. I lived in New York City once in 2013 and I loved it. Baltimore, Maryland, USA, Russia, cool. More USA, Italy. Yeah, I lowered the bit depth and I guess it's better now. Of course, quality is not as good, but I think it's less laggy. Cool, thank you. Who gave me the tip? Curry, I don't know. Yeah, thank you so much. Lag on. Yeah, I lowered my bitrate because my internet today is not great. Poland, Ukraine, Quebecois. It's so nice to have people from all around the world. It's so good. Here where I live, I can't get to meet many people from other countries, so it's always a pleasure doing this live. And Natalia, Brazil. The day after tomorrow, we're gonna have a live too, totally in Portuguese, but not in this channel, in my new channel, which is going to be completely in Portuguese, because my Brazilian fellows always complain, why you're not doing content in Portuguese anymore? So I'm going to start doing it again. Okay, guys, I think we are good to go. Can we start? Did you get your water, your tea, your cup of coffee? So what we are doing today, I have this here. This is, you might believe it or not, this is a MIDI controller, or it's not a MIDI controller yet. So what's going on here? The idea today is getting this circuit and making it into a full MIDI controller, MIDI class compliant device that I'm going to plug in Ableton and make it a MIDI controller. Today, I'm not going to go or explaining you in depth about what's going on here in the circuit. I left here in the description the link for the Nerd Musician Pro. There you can find my courses. And there you can also find the DIY MIDI controller workshop. The DIY MIDI controller workshop. It's a free course, free 1-hour course, filled with information where I teach everything you need to know about the Arduino, how to wire the button, how to wire the potentiometers, how to use the breadboard, which is this thing here that I use to make connections without soldering anything. So a breadboard is great for prototyping. But what I have here is 3 buttons, 3 tactile buttons, and 2 potentiometers. People also call potentiometers as knobs, but they're just regular potentiometers. They are B20K ohms. They are linear 20K ohms potentiometers. Could be B10K, B5K. Everything would work. So the challenge today, and I would say is really a challenge, is coding this MIDI controller from scratch. And what I mean by that. A MIDI controller works, let's come back to that. The MIDI controller works with this thing here, which is an Arduino. An Arduino is has a microcontroller, or something that with some programming language can be programmed to do something. It has inputs and outputs, and here I'm connecting buttons and potentiometers and its inputs, and then with some code that we're going to write today, it can do a bunch of things. You can use it to control LEDs, to control motors, to do, I don't know, home automation. You can track the distance of an object to do a object avoiding robot, but you can also do a MIDI controller. Even synthesizers you can do with the Arduino, but not today. So today we're going to program a MIDI controller with this Arduino, and we are going to do this from scratch. Sometime maybe you already follow me here, and you already downloaded my code, you used it, and you can see that's a lot of things, and you're probably like, I have no idea what's going on there. And part of what I do is allowing you to just use my code without actually having to understand what's going on. And that's pretty powerful. You don't need to learn how to code in order to build a MIDI controller. And I'm releasing videos on my YouTube now where I actually teach you how to program, the code, the basics. And inside my courses, I teach to do that too, but also do a bunch of things in a way that you don't need to learn how to code in order to use buttons, potentiometers, encoders, motorized faders, multiplexers to increase the number of inputs and outputs, LEDs, displays, and a bunch of other things. But today I'm going to do for buttons and potentiometers, which are the main things you're going to use most of the time. And feel free to ask questions in the chat. I'm going to do my best to answer. Tulio Felipe, e aí, meu? Curi, can you use any Arduino? I think I have an Uno around. So in the DIY MIDI controller workshop, I highly recommend you to do it. I talk about which Arduino to choose. So why should you use an Arduino Pro Micro instead of the Leonardo? So here I am using the Arduino Pro Micro. The Arduino Pro Micro has the same chip, the same microcontroller as the Arduino Leonardo and the Arduino Micro. So Micro, Pro Micro, and Leonardo has the same chip. So this tutorial will only cover Arduinos with the chip. So let's start writing something here in the code. So guys, before I finish this talk about which Arduino, here is where we are going to write our code. So I'm not going to talk about every little thing I do here. So you might be lost in something, so I apologize about that, but we have a lot to cover. But this will be recorded, and feel free to watch as many times as you want. And there will be more classes coming to my YouTube where I teach how to code different things. Okay, so this code works with Arduino, Micro, Pro, Micro, and Leonardo. Yes, you can use the Arduino Uno. You can use any Arduino to make a MIDI controller, but there are different caveats. In order to make it MIDI class compliant or plug and play, you have to use an Arduino that can be plug and play, and not all Arduinos can. So Arduinos with the AT-Mega32U4 microcontroller will work. So Micro, Pro Micro, and Leonardo for this tutorial. But you can use 95% of this tutorial, of this code, and only change the MIDI library to use with Arduino Uno. However, Arduino Uno will require you to use an extra software, which is Hairless MIDI, which is super buggy right now. So I highly recommend using those Arduinos, okay? So let's start with this. Writing a code can be a little scary, because you open this Arduino IDE. So this is the Arduino IDE. Oh, I'm sorry, you're not looking at my screen. Okay, now you're... So this is the Arduino IDE. So this thing here, it's a software, which is a programming environment where you're going to write the code, and then you're going to upload this code to the Arduino through the USB. So you write here, and it has some functionalities that it uploads the code to the Arduino. And it starts like this, basically with nothing. So what we want to do is writing the code, and this will be some people that have some familiarity with coding. They will be more comfortable in this life. Maybe you don't have, and you'll be like, oh, what the fuck? But please try to understand the concepts. And if you're more experienced, feel free to get this more nerdy live for you. Okay, just one more question. What about Teensy? Yeah, Teensy are perfect too, but the Teensies also use another library. So 95% of this code will work with any Arduino. You just need to change the MIDI library. The Teensies use a specific library, and Arduino Nano, most of the Arduinos use the MIDI library, and the Arduinos that I mentioned use the MIDIUSB library. Okay? So I hope that today you at least understand the concepts, how to think like a programmer, and how I think when I have to solve something. I don't know how long this live will be. I was thinking, should I do it fast and just show how I do it, or try to explain everything? And I'm going to try to explain most of the things. Okay, guys. Oops, sorry. I hope you can see well. Okay, so let's go. First, we are using 3 buttons and 2 potentiometers. Let's do first the buttons, okay? So, first thing I need to do is declaring the pins, is telling the Arduino in which pin I am connecting each button. So, for that, what I do first is creating a variable, which is a container, that's going to store whatever number I want. So for example, I'm going to create a variable, which is a type of byte. A byte is a variable that can store a number from 0 to 255. It's a 8-bit, it has 8-bit resolution. You have variables that are bigger if you want to store a bigger number, but for now, the byte will work. So for example, I could do Arduino pin 1 equals 2, because I am using pins 2, 3, and 4. And then, for example, 3 and 4, and then do pin 2 and pin 3. And then use this in my code. But every time you repeat things, usually there's a better way of doing. So the better way of doing, instead of repeating variables of the same kind, is creating an array, which is a list. So the way you create an array, so I have button pin is going to be the name of my array. Then here you're going to type how many buttons you have or how many items you want to store here. And then here inside curly braces, you type the numbers you want to store in this list. So my button pin is a list which has 3 items, and the items are 2, 3, and 4. Instead of using 3 here, I'm going to use another variable to store this number 3, because I'm going to use this number 3 many times in my code. So for that, I'm going to call any number. So it's the number, oops, sorry, that's not any number, it's like a number of buttons. Any buttons. It needs to be, in order for me to use here, it needs to be a constant and integer, but don't worry. What matters is that I have this variable called nButtons, which contains the number 3. So I'm going to use it here. Okay, so I already have my button pins here stored in this array. Now I want to tell the Arduino, or I need to tell the Arduino, that I am using those pins, and those pins are inputs. So the way you do this is pin mode, and then you tell which pin you have. For example, if I'm using pin 2, and then what kind of pin? Is it an input? Is it an output? In this case, it's an input. But it's not only an input, it's an input pull up. And so what is this input pull up? Let's come back here to my screen. Sometimes when you see Arduino button wiring, you will see that they use a resistor. So for you to use a button, you need a resistor for X reason. But instead of using an external resistor, you can use a resistor that is inside the Arduino. So for you to use an input with this built-in resistor, you need to say here in the code, input pull up. Using input pull up also will do something inverted then in the code, but let's not worry about that. So what I want to do here, instead of manually declaring each pin, I'm going to create a loop, which I'm going to explain you what it does. So this is a for loop. A for loop is a loop, something that's going to repeat itself. Let's just, okay. So a for loop, it's something that's going to repeat itself X many times. So don't worry about how you use a for loop. I'm going to do a video after explaining you. But what I want to see is that it's going to repeat it 3 times. So what it happens here is that first time in the loop, I have this variable I, which starts as 0. Next time in the loop, my I is 1. Next time in the loop, my I is 2. Next time in the loop, my I is 3. And what happens here is that as long as my I is less than 3, I'm going to keep in this loop. So first time it will be 0, then 1, then 2. Next time it will be 3, so this will be false. So it's not less than 3 anymore. So then I'm going to exit the loop. And what I want to do here is that I'm going to use my array, my list, and how I use one of these values here. I type the name of my list, and then inside brackets, I tell the index of that item. So if I do this, button pin at 0, input pull up, it means that button pin my list at index 0, which is this, which is 0, 1, and 2. So my pin 2 is an input pull up. If I do this, it means that my pin 3 is input pull up. And if I do this, my pin 4 is input pull up, because I'm calling the index of this list. Index 0, index 1, and index 2. But remember that my I, every time I go in this loop, it increases by 1. So 0, 1, and 2. I'm going to use this I here. So first time I'm declaring pin 2 as input pull up, then second time pin 3 as input pull up, and so on. So that's the beauty and the magic of using a for loop with arrays. Okay? Let me just see. Do you use resistors connected with a button to ground for signal quality without interference? No. We don't need to use a resistor with a button for interference. We don't get any interference because we're actually using the input pull up. Or let's say, with this resistor built in, that's what we're getting. We're always draining the current to ground or whatever. But yes, using the resistor, we're gonna have this super stable button. And in this case, the built-in resistor. Sometimes it will pull the ground and sometimes it will pull to 5 volts. And in this input pull up, we are actually pulling the reading of the button to 5 volts. So when we read, when it's not pressed, it will read 5 volts. And when we press, it will read 0. But don't worry. Okay, guys, another thing I want to do here. So I'm gonna comment declares the button pins. What I want to do here is start our serial monitor. Our serial monitor will allow us to see message then in the serial monitor. Of course. So instead of programming the MIDI controller sending MIDI message right away, I want first to just see messages in my screen. Like if I press a button, I want to see a message like button pressed or button on instead of sending MIDI, because it's easier to debug. So I always use a lot the serial monitor to debug before actually trying to send MIDI. And you'll see how we do that. So here in the void setup, this will only happen once in the code. When you start the code, it will happen once. Then, here in the loop, this will happen repeatedly, one after the other. So then here we're gonna read one button, read the other, read everything, do whatever we want to do, then read again really, really fast. So here we are going to, let's say, run our buttons program. And this program I'm going to write separately. I could just write here, but I'm going to put inside, let's say, it's like a container or a box with a chunk of code, which is called a function. In this case, a void function. So a function called buttons. So everything that I put here, since I'm calling this function here in my loop, every time it gets here, it will read everything that's inside this void function. So here, what I want to do is creating a for loop. Exactly the same way as the other one. And here, it's where everything is going to happen. Just let me test my code to see if I don't have any error. Yeah, done compiling, I don't have any error so far. So the first thing I want to do here, let's create a variable here that is going to store the state of the button. So button is state. So I'm going to use the same thing here. So I'll have a list, an array of button states. And I don't need to declare them now because they will change. So we don't need to have a fixed value, but we can start with 0 just for clarity. So here I want to store in each button state. So remember that I can use the I here. So button state at I, if it's 0, I'm going to store the state in the first item of this array. And every time I go in the loop, I'm going to store in the next slot of my array the information that I want. And here I want to read the pin. And to read a pin in the Arduino, you call digital read. And then you set the pin you want to read. And in this case, it's button pin at I. So every time this happens here and the code happens once after the other in order, I am storing the state of the button. So if I'm pressing the button, it's going to be on or off, or 0 volts or 5 volts. So I need to store this to use it later, okay? So what I want to do is print in my serial monitor what I'm seeing here, okay? So I'm going to use this function called serial print, and then I'm going to print the button state at I, and then I'm going to next time in a small space. So when I do columns here or quotes, you can write something inside, or here I'm just using a space. So I'm printing, giving a space. Next time I'm gonna print the next value, give a space. Next time I'm gonna print the next value, give a space. And then I'm going to exit the loop, and then I'm going to print a new line, which is serial.println. I'm going to press here to verify my code to see if I have any error. Okay, no. So now I'm going to upload the code. And then I'm going to open my serial monitor. And here you can see that I have 1, 1, 1. So because I'm using input pull up, when it's not pressed, gives me a 1. And when it's pressed, give me a 0. So you can see that I have my buttons working. But see that I'm sending really fast one value after the other. Send, 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 send. And we don't want that. What we want is to send a value only when the button is pressed or released. So now it's when we need to start thinking, how can we do that? And in code, in programming, there are tons of ways of doing the same thing. So what I want to do here is storing the value now, and then in the next time I compare the value now with the value before. So I need to store the previous state of the button. So I'm going to create another array, but now with the previous state. And this one is the actual state. Okay, so here in the end of the for loop, or before we do that, let's create here, in order to print this, I'm going to create an if statement. So if something is true, then run the code inside this if statement. If it's false, just skip it. So if button state at I is different than button state or button P state at I, then do this. So if this is true, print this. Okay. Do you understand the concept of if statement? If something's true, execute that in the code, execute that in inside the curly braces. And this is the different. If I want equal, I do like this, and there are different operands. But anyways, so if this is true, do this, and now store in the button P state the button state. So when this happens, we're storing this state in the button P state. So when you only use one equals, it's like store this here, okay? This is different from this, okay? Okay, we don't have any error. So if button state is different than button P state, print that and store that here. Let's upload this and see what happens. Okay, so I didn't get anything, so I probably did something wrong here in the code. So button P state, button state. Let me see what I'm doing wrong here. Let me see if I'm checking, putting, and there's something about doing code is that it will not work a lot of times, and sometimes you just have to try it out and different things and see what's going on. And doing this live was like, oh my god, things are not going to work. So what I'm going to do when I get those problems? Okay, I'm still not getting what I should be getting. So let's try to see again. So let me see if I... And if you're seeing what I'm doing wrong, please feel free to correct me in the chat. So button state, digital read button pin. If button state at I is different than button P state at I, do this, and then button P state. So what I'm doing wrong here, let's try it again, but I don't think it's gonna work. Yeah, sometimes it's something really obvious and just doesn't happen. Just doesn't happen. So if buttons, let's try it again. If button, let's comment this. So each button P state. Let's print this outside here just to see if we are getting the same thing we were getting before. Okay, I was not declared in this scope. Let's do it again. Let's think again on what we are doing. So we have this for loop here. Yeah, we're reading the buttons here. So first time we read the button and then we print. We should get the same thing as we were getting before. Yes, that's fine. So if button state I is different than button P state at I, then all right so far. And if this button state is different, it should store in the button P state at I the current button state. So I don't know if it's gonna work because it seems it's the same thing we were doing before. Oh, I know what's going on, I know. The problem is this serial print line here. Okay, so because I'm printing what I want to see, but then I have the serial print line that's giving me new lines like crazy, and I just can't see my value. I guess that's the problem. Woo! Perfect. Okay, so let's do it in a better way. So here we are going to, instead of printing that space, we're going to print a new line. And I'm going to do something here. Serial.print. And then I'm going to write some things to know which button is which. So button. So I'm going to write this, and then I'm going to set I. So I'm going to print button and then which index I am, and then the state, and then the state of that button. So okay, button. Okay, so we should be good. So yeah, guys, sometimes the code doesn't work and it's just something really stupid. And then you waste a lot of time. Okay. Oh, the dots there are in the wrong place, but anyway, so button 0, 0, 1, then ta 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 and ta ta ta. Oh, I'm going to show you my actually what I'm doing here. So okay, so buttons are working. So if I have my button pressed, send something, and if it's not pressed, or like when I'm pressing, it's sending the state, and when it's not pressing, releasing, it's sending its state only when I change the state of the button, only when I press or when I release. Another thing I want to do here is that I'm going to send different messages, MIDI messages, when it's pressed and when it's released. So I want to do something like if button state equals low, which is 0. Remember that the state is inverted. Let me come back to me. Remember that the state is inverted. It's giving me 0 when pressed and 1 when it's not pressed. So 0 is low and 1 is high. So high and low. So here, so when it's low, when it's pressed, I want to type button. The only thing I want to type here is button, again, button I. On. It can be like this. So button I on, and then a new line. If this is pressed, if it's not pressed, we can do else. So if this is false, do something else. So I'm going to print the opposite, which is off. So let's check that. So let me show you here. So you can see my button 0, it's on, off. Then my button on 1 is on, off. And then the 2 is on, off. So it's, you can stop here, but I don't think I'm going to be able to reproduce a problem that can happen with buttons. But see here, I only pressed once and I got 1, 2, 3, 4, 5, 6 readings. So why? Tell me why in the code. Why, if I pressed only once, I got 6 readings? So I'll tell you why. This is called bouncing. So when you have a button, when you press this button, it has 2 terminals that touch. And sometimes when you press it or when you release it, it really bounces, like, but really, really fast. And this is a common phenomena that happens with buttons, switches. And imagine you only pressed one button and then you got, you don't want that. So we need a way to figure out how to avoid bouncing. So we need to implement a debounce algorithm. Oops, I never know which window is which. So now we need to think about how can we do a debounce algorithm. Sometimes you look in the code and like, what the hell is that? So one way of doing is the following. And that's hard. What I'm teaching you here today, I literally took months to understand. And to understand the concept, and understanding the concept, writing the code. Because I wrote all my codes by myself. I learned with others, but most of the things, like 95% of what you see in my code, I wrote from scratch. And there are different ways of doing it. And debounce is a little hard to understand, but keep with me. So one way of doing is when you press the button, it will touch the terminal for the first time, but then it might bounce. And this bounce is really fast. It lasts like a couple milliseconds. So what we want to do is when we close the circuit for the first time, we want to stop reading the button for the next X milliseconds. So when we touch, like when it happens for the first time, we want to wait X milliseconds to read again our button. So this avoids that we read that bounce that we don't want. So how we do that? Let's think that we need a timer. When we close the circuit, this timer starts. And we keep rolling this clock. And if we come back to that part of the loop to read the button, and the clock haven't reached a certain time out, let's say, we're not going to read that button. But if the counter is already bigger than that timeout, we can read the button again. It means that it's not the bounce anymore. Okay, so every time we press the button, we need to, let's say, zero that clock, that timer. So we close the thing, we zero the timer. However, we don't have a timer, let's say we don't have a timer that we can just zero. Oh, I think that my internet is a little... Can you hear me? I think my internet was a little bit bad. Is it better now? Okay, I think it's better now. Okay, guys, water, please. Please let me know in the chat if it's a little choppy. Okay, try to decrease the bandwidth, the bitrate a bit. Okay, so let's come back. But we don't have a timer that we can just press a button and it comes back to zero. But we do have a timer that starts when the Arduino starts. And this timer is called millis. We're gonna write that again, write that. But let's say that it starts when the Arduino starts. So every time we touch the button, we need to save that timer. We need to save the state of that timer. Oh, we press that button, we need to save that timer. So let's create a variable called, let's say, and this needs to be an unsigned int, which is a variable that can hold big numbers because we're going to store big numbers, like count a clock in milliseconds, so you can get like pretty big numbers. So last the bounce time can be this. Okay, let's the bounce time. We're gonna have one for each button. We don't need to start with anything. And when we press this button, we want to record what time is it, basically. So we're going to store the current time. So every time we actually press the button, we store that time. Now we need a timer. So button timer, which is going to, how do we know how much time has passed since we pressed the last time? So if when we press the button, our clock was 10, if the millis now is 15, we can subtract millis from our last debounce time, which is 5. So every time we subtract millis, which is always counting, from the last time we stored time, we know how much time has gone. Okay, so now we also need to keep track of the time. And we are going to keep track of the time every time in the loop. So button timer equals millis minus last debounce time. I know it's a little complicated. How much time has passed since we pressed a button? So when we press, we store the time here. And here we keep track in this button timer of how much time has passed. So the time now minus that time we just stored. Okay, so now remember that we only want to read those buttons if our time is more than X milliseconds. Okay, so let's create another variable, which is button timeout, let's say. And that's just one timeout for everything. How much time do we think that is enough for us to avoid bouncing? We have to test, but something around 10, 15, 20, 30 milliseconds is enough. And the way we are doing here, we are not stopping the code in order to wait. So that's why we're using millis. It's a clever way of counting without stopping, without using delay, because there's the function delay, which actually stops everything. So let's use 10. So it's going to be 10 in milliseconds, milliseconds. So let's start with 10 milliseconds. So here now, we're going to do if our button timer is greater than our button timeout, do this. So if our timer is bigger than the timeout, now we can do this. We're done compiling, or we don't have any error. Let's see what happens. So, yeah. I'm really trying to do some bouncing here, but it's really working, okay? So if in your code you have this of like pressing one button and getting multiple readings, it means that you are having bouncing. And at least in my code, there's always a variable for the bounce. Sorry that the name of the variable sometimes changes. Here is button timeout. But here is where I can change how much time I'm waiting, okay? So guys, that's basically all we need to do for reading the buttons. Not with the MIDI message, but this is the first part of our live. Next, we're gonna go to potentiometers, and I'd like to see your questions. So JS asked, should it be an unsigned long? No, because I'm only storing the number 10. This never changes. What changes is I'm going to put down here. What changes is the timer. The less the bounce time and my button timer. This is what changes because the clock is always changing. But what I am comparing to, which is always this 10 milliseconds, doesn't change. So I don't need a variable that big. I can even use this. But I'm going to use an int. Okay, I think integers have 16-bit resolution, while byte is only 8. So integers also have negative and positive or big numbers. An unsigned int is basically the same int, but without the negative numbers. So you get all the negative numbers, all that space, and use to make to use it as positive too. So it make it twice as big. Okay, so also JS means in line 9 and 10. So man, yes. So that's great that I'm doing with you because so JS pointed something really important here. I used int, and I remember that I was stuck in my code for weeks, for months, I don't know, because it didn't work. I didn't know why. And you know why? Because I was using int instead of long. Because integers are not long enough for a clock. They're not long enough. So actually, you need to do long. Oh, I would get crazy here not knowing what I was doing wrong because I was not going to realize that I did that wrong. So thank you so much, JS. So yeah, we should use long for millis. Nicolas, will it be too hard to adapt with MIDI velocity? Yes. With this button is impossible because this button only has 2 states. But no, it's not. This code, yes, it's hard to adapt, but it's doable. But it's not inside our scope today because it's a lot going on with velocity. Okay, so yay, we did buttons. We need now to do potentiometers. So let's do some division here. I always like to do some space like this between things in my code, just to make it easier to understand. So now we're gonna have a potentiometer function. So we're going to create also a void function called potentiometers, just to make it consistent. And we're gonna do some things that are similar. We are going to use const int now n pots for the number of potentiometers we have. We have 2. We're gonna declare the pins, now pot pin, of our potentiometers. So here I have my buttons in pins 2, 3, and 4, and my potentiometers in pins A0 and A1. So A0 and A1. So A0 and A1. Then I'm going to already start with my pot state, because I'm going to have a variable to store the state of the potentiometer. However, the potentiometer has a resolution of 10-bit, and a byte is only 8-bit. So I need a bigger variable. So I'm going to use int now. So why I use byte instead of int, instead of just using ints for everything? Because bytes take way less space in your memory. So you're going to need memory, my friend, in the future. When you start adding more buttons, potentiometers, and things to your code, you might reach a limit. And using a byte is a good practice for you to have enough memory. So pot state. And okay, we don't need that now. That's it for now. Let's say I am going to start also with a for loop. So now the size of my loop is my n pots, the number of pots. Okay, so I'm going to now, using my pot state, I'm going to store here the reading of the potentiometer. And how we do that now, here, see how we did? Digital read and button pin. Now is analog read and pot pin. Now let's do some printing, just for us to see what's going on. So I'm going to print pot state, and then I'm going to print some space, and then here I'm going to print a new line. Hopefully I will remember this new line. Okay, so let's see what we have now. Okay, you can see here that I have my reading from 0 to 1023. And see that I'm not touching the potentiometer, and it's moving by itself. Sometimes when I touch it, see? So this is called floating. Sorry, you're not seeing what I'm doing here. So see, I'm not touching. And it is a little crazy. And this is called floating. This is because of noise. Your body interferes in the environment, electronic devices, lots of things interfere in how this current is flowing here. And that will make the reading always jittery. There are algorithms that we can use to smooth the reading. We're not going to do this here, but what we're gonna do is first see that we have a reading from 0 to 1023, and we don't want 1023. We want 0 to 127. Why? Because 0 to 127 is what we use in MIDI. So just let comment here reads the potentiometer. So we need to convert this reading to a range that's suitable for us. So instead of using pot state, I'm going to create a new variable called MIDI state. So what I want to do here is that MIDI state, I want to store this value here, but in a different range. How we do that? We can use the map function. How do we use the map function? It takes 5 arguments. The first argument, the first thing you put, is the variable you want to change the range. So this. The second is the minimum value that the original range has, then the maximal range, then the new minimal range, and then the maximum new range. So this map function is mapping this range to this range. So now my MIDI state will be in that range. So let's print MIDI state now instead. See that now I go from 0 to 127. Sometimes it doesn't go until the end, and sometimes it's because of the breadboard, the component. And you can change some things in the code. You can change the minimum and the maximum. But let's not worry about that now, okay? Just know that we changed the range. Again, same thing with the buttons. See that we are sending many messages at once, one after the other. This will crash our computer. So we just want to send a message if the state now is different from the state before. Same with the button. So now we want to let's say create a MIDI P state. So if MIDI state is different than MIDI P state, do this. And here, let's store in MIDI P state what the state is now, which is MIDI state. And I'm going to delete this serial print to not kill me again. So now, if the state is different, output the message. Let's put another serial here, serial.print. So let's write here pot. And then the number of the pot. And then we can take this out from here. So we're gonna print pot, the index of the pot, and then a space, and then the actual state of the MIDI. So we should only see messages now if we move the potentiometer. Oh, you're not seeing me. Okay, so I should use a new line here. Okay, so now you can see that it stops, but let's see something. Sometimes I'm trying to find a place that the noise will affect everything. Sometimes we have more noise and oh, here. Oh, see that I'm touching and it's sending message without me wanting. So that's a problem. So we want to send the message only if the difference in the value is bigger than a threshold. So we want to send a message only if the change in the values are bigger than something, because when it's bigger than something, we know that's not only noise, that's a small change, it's actually we moving. So we want here to compare the pot state with the previous state and see if this variation is bigger than X. Where were I was reading the comments and I got lost. So we need a variable that I am going to create here. We don't need always to create a global variable. So all the variables that are here, they are global and then can be used in any place in my code. When I want a variable that I'm only going to use locally at that time in the loop, and in the next time in the loop it will change, I can just declare it here. But I could declare it at outside. So I'm going to create an integer called pot variation, pot var. And this pot var is equals, or I'm going to store the pot state minus the pot p state, which I haven't created yet. So I'm going to create this variable now. So I'm creating that pot p state. Let's put here. So previous state, actual state, and MIDI range. Okay, so if my pot, I want to store this variation, pot state minus pot p state. So here, at the end of my loop, I want to record the pot state in the pot p state. That's how I know which state was before. So here I'm saving the, no, sorry, that's the opposite. Now I'm saving the value now in this pot p state. So next time I'm going to read another pot state, and I'm going to do the subtraction. But if my pot state is 20 and my pot p state is 30, I'm going to get minus 10. And we don't want negative numbers here. We're going to use as Ganemi said, use absolute. So we're gonna use ABS. So ABS makes any value positive. Cool. Okay. So now we have our variation here, and we want to only run this if the variation is bigger than something. So let's create a variable called pot threshold. And that's how much the potentiometer needs to move in order to be considered it's a human moving the potentiometer, not only noise. I'm going to set 20. Let's see how it goes. So now here, if pot threshold, or if pot var, if my variation is bigger than my pot var, run this code. By the way, I'm always pressing Command T to organize the code. So if pot var is bigger, I'm doing what? If pot var is bigger than this, if my pot variation is bigger than my pot threshold, if my variation is bigger than 20, run this code. So let's upload this. So I'm not getting anything, so I'm probably doing something wrong here. So if my pot, let's print this pot var just to see what's going on. Yeah, we do get some variation here, but okay, so that's definitely not our problem. So if our pot variation is bigger than the threshold, let's try to print something here to see if we are arriving here at any time. Yes. So if we move the potentiometer, we should see a yes in the serial monitor. So nope. So what we are getting here, so we are not arriving there. So what we are doing here. Okay, so let's think again. We have pot state. We are calculating the pot variation. Let's, instead of maybe, I don't know if we should, yeah, we can use a pot var, a local variable here. So if pot variation is bigger than pot threshold, let's decrease this. Okay. So let's put a small number here. Let's do it again. So Nicolas said you need to write the state inside that if you just added. Let me see something here. So it's getting this crazy thing here. Let me just check what, so Nicolas said you need to write the state inside that if you just added. So if we are here, you mean change to here. Let's see. Actually, we're gonna change this code a lot. Yes, Nicolas again saved my life. Man, talk to me, I owe you. Okay, so yes, we should declare there. Let me just put a space here. And this is something that gets you crazy, that sometimes you need to declare inside something and sometimes outside, and gets confusing of where. So I want you to see something here. Look at this reading. 14, 15, 17, 18, 19, 21, 22, 24. See that we are skipping values. And let me increase this pot threshold to a bigger number just for you to see. See that I'm skipping way more values. So yeah, my potentiometer is not jittery, but I am skipping tons of values, 55 to 58 to 61. Why? Because we are only doing this, oops, sorry. We are only doing this if the variation is bigger than this threshold. So we are waiting the variation to be 20 to do something, then wait the variation to be 20 to do something again. So we are doing like it by increments of 20, which is really terrible. Of course, we can decrease that var threshold, but we might get a jittery reading. So what we do, now we get into the other complicated part here. Just like with the debounce, we need to think a new way, a new algorithm to process that. And one way of doing this is, let's think like this. When you move the potentiometer for the first time, you open the gate. And then after you open the gate, you keep reading everything for X amount of time. So when you move the potentiometer, you open the gate. And this gate keeps open, reading everything for X amount of time. So we need to think about that timer again. So when you move the potentiometer, you start the clock. Every time you move, the clock gets zeroed. Every time you move, the clock gets zeroed. And it will read everything until it reaches a maximum, a timeout. So it's kind of similar in the sense that we're going to use this timer and we need to think, how can we start the clock? How can we compare when the clock reached to a certain number? So it's kind of similar. So we are going to create variables here. So unsigned long now, which is last pot time, just to be consistent. So last pot time. We're going to need also a pot timer. Last pot time and pot timer. Okay, so let's see what we can do here. So let me copy this variable, last pot time. So every time, so how do we know when to reset the clock? So we need to reset the clock to store that millis in the last pot time. So when that happens when this pot var is bigger than a threshold. Okay, so what I want to do here, I want to change something. So here, when pot var is bigger than the pot threshold, I want to store in my last pot time the value of millis. Okay, so now when I moved the potentiometer, I'm resetting that clock. And we also need here to keep track of that, of how much time has passed. So let's say resets the clock here. So now here we need to store in our timer how much time has passed. So it is millis. Guys, I'm getting an error again from YouTube. I'm going to decrease my bitrate until I don't have bitrates anymore to decrease. So 2000. Okay, and hopefully it will get better. But okay, so here in my pot timer, I'm going to subtract millis from my last pot time. So keeps track of how much time has passed since we moved the pot. Okay, so here we are zeroing the clock, and here we are keeping track of how much time has passed. So we are going to do this if we're going to do this if pot timer is bigger than a variable that we're gonna create. No, wait. If pot timer, so no, now it's the opposite. Now it's the opposite. So if our timer is smaller, because remember we want to leave this gate open for just a certain amount of time. So while our pot timer if is smaller than that timeout, we want to run this. So if our pot timer is less than, let's say, pot timeout, do this. So, okay, I need to, of course, declare this variable. So, pot timeout. So for how much time do you want to leave that gate opened? I found that 300 milliseconds works fine. So pot timeout, let's upload. So I'm gonna show you my So I don't know if you can see exactly, but what I'm doing here is that I am moving my potentiometer and it's sending all the message that I want without skipping any value. And after 300 milliseconds, which is pretty fast, it's almost unnoticeable, it stops. So what you can do here is changing the spot threshold. You can decrease that, but if you decrease that too much, you might get some flickering from your potentiometer, or like it can change its value without you touching it because of noise. So you can always increase this spot threshold. Okay, guys, so we are basically done. I'm still decreasing my bitrate here because it's just not, it's never enough for YouTube. And questions, we're almost there, Please let me know in the comments. Questions, we're almost there. We have buttons and potentiometers now working in the serial monitor. So the only thing we need to do now is adding the MIDI capability. So that's the easiest part. So guys, are you with me yet? Are you alive? Do you have your brains yet? I hope so. Looks hard, but you do one thing after the other, one concept after the other, and you keep increasing the code until it's done. So the code in my course, the making music with Arduino, is a code that has tons of things, and you look at that and you can get really scared because it's just too much. Because it's not only buttons and potentiometers, it's encoders, LEDs, motorized faders, everything in one code. It's really organized, but it's too much. But it's how it starts. It starts with one thing and then you add another thing. So guys, I know that it is choppy. I don't know exactly what to do anymore, but hopefully you can hear me. So yes, sound is good. So let me just show you here in the serial monitor that we are getting button on off for all the buttons, and we're getting a good reading from our potentiometers. Still, the reading of the potentiometer is a little jittery when it moves because it opens the gate and everything enters. And there's an algorithm that I implement in the other code in the making music with Arduino that smooth this reading out, so it's so super smooth. But then it's another thing. So if you can download this stream later, it will be available on my YouTube. So you can just come back to the channel and it will be there. I'm not going to delete or hide. So let's go to the MIDI part, which is our last part. And for that, we're going to use a library. So to use this library, I'm going to type include MIDIUSB.h. To use this library, you need to come to Tools, Sketch, Include Library, Manage Libraries, and type here MIDI-USB, and find this MIDI-USB by Getty Grewal. I just released a video last week about how to use this MIDI library, the MIDI-USB, which allows you to make the Arduino Pro Micro, and Leonardo into a MIDI class compliant device. And we need an extra thing here. I'm copying and pasting here because there's a lot of things. So I'm going to paste this. These are two functions to use to send note on and control change. Let me just organize the code a little bit, put this so it's not too confusing. And here. Okay, so what we want to do now is using this MIDI-USB library to send a MIDI note or control change. Note with the buttons and control change with the potentiometers. So what we're gonna do is coming here where you remember where we are sending this button on off. It's here. So here we're going to type the name of that function, note on. So we want to send a note on. So note on, and inside those parentheses, you need to type 3 arguments. The channel, it's the first, then the pitch, then the velocity. So I'm going to create this variable later. So for MIDI channel, then the note number, and I'm going to use an array to store the notes that I want. So I'm going to, first button is going to play the first note of my array, second button will play the second note of my array, and so on. And for note on, I know I want velocity 127. So let's create the MIDI channel variable. So in the MIDI-USB library, the first channel is 0. So it goes from 0 to 15. And I want to, let's create this array for the note numbers. And I'm going to use notes 36, 38, 40, which is a C, D, E. I'm going to put here. Okay, so I have my array with the note numbers. So here I'm sending a note on in MIDI channel 0 with the note number that corresponds to that index in the array with velocity 127. Now in my note on, my button off, I'm gonna do the same thing but with velocity 0. Let me compile the code. Let's upload this code. Okay, we're still getting in my serial monitor, but now I want to open MIDI Monitor, which is a software that I can monitor the MIDI incoming. A way to change its name, but we're not going to talk about it now. So we are not. Oops. See something crazy that happens? Instead of, and I'm going to mute my Ableton because we don't want spoilers. So instead of sending one note after the other, it sent everything together in a crazy way. So there's one more step, and I always forget this step, which is we need to call, let me come back to the code, thing. Every little thing we want to send with the MIDIUSB library after we need to call MIDIUSB.flush. You can type several notes and control change, and only in the end you can call flush if you want to send all the things at once. But I don't recommend that. I recommend to always call MIDIUSB flush after everything or everything. So, okay, let's come back to MIDI monitor. And yeah, now we have note 36, 38. You can see the velocity. And 40. And if I move my potentiometer, I don't have anything yet. And in Ableton Live, I have a piano here. So and some of you usually ask, oh, yes, you can. It is happening one after the other, but I think it was a little buggy. It's why it's so slow. Okay, I'm trying to change my output again. Okay, so let's come back here. So, and please guys, if you can't see me, let me know. Anyways, I am sending notes, and you can, it happens one after the other, but it's so fast that you actually hear like they are simultaneously. Okay? It's a shame that the internet is so bad, and like I have no idea why. It used to be good. Can you hear me? Yeah, I think it's in my side, the laggy internet. Okay, let's try it again. Let's try again. I know that's not going to be great, but we're almost there. Let's see if we can finish this. Let's come back here to the code, and let's just add. Yeah, I can program better internet. I'm gonna try then other videos explaining this in a recorded video, and hopefully it will work best, okay? But okay, let's do the same as we did, but now for control change for the potentiometers. So control change. Now, let's go to where we are sending those prints, which is here and here. we're gonna send control change, which takes 3 arguments. One is the MIDI channel, so MIDI channel. Then is the control, or the control change number. So we're gonna do the same, but instead of note number, we're gonna choose our control change. And then the value, and the value here is the MIDI state. So let's create a variable now for control change. So cc at handpots, and let's choose, let's say 11 and 12 for my control change number. So here, where we were printing, now we are sending MIDI. Yeah, I'm trying to change as much as I can here in OBS, but results. I tried limiting the bitrate now, which I didn't do before. Is there anything I can do? I don't think so. I am doing 30 FPS, so it's not a big deal. Okay, so yeah, guys, sorry, that's the best I can do. So hopefully you're getting the audio and you can read the screen. But anyways, now we just, I think we uploaded. Let's see. So in our MIDI monitor, we should see now a potentiometer. And yeah, we are seeing. And we are going to, again, I forgot, it's super choppy here, and that's not the internet this time. It's because I forgot, guess what? MIDIUSB. So now, oh, sorry. I did something wrong here. Here, MIDIUSB.flash. So now let's go to MIDI monitor. We have our buttons and we have this great potentiometer here, which is working. Channel 1, so control change 12 and control chose. And so if we go to Ableton, in preferences, we already heard, but here in MIDI, you can see that I have my Arduino Leonardo. And track is for playing notes and remote is for mapping. So we want both. So if I press here and move the potentiometer and press here and move the potentiometer, now I mapped that knob. So if I play the note, oh, sorry, you're not seeing my... So I mapped here. So now I have a reverb here. And a delay here. So it is working as a full MIDI controller. Yes, guys, I know that the internet was horrible, unfortunately, but we got to the end. We succeeded, and this live will be recorded. You can watch it, and but if you want, less laggy, less choppy me, or tutorials. Also, you have my courses here below. You have the Nerd Musician Pro, which is a 3-course in one. Sorry, you're not seeing me. You have the Nerd Musician Pro, woo, which has 3 courses: the Making Music with Arduino, the Arduino Programming, and the KiCad PCB Design. The Making Music with Arduino is where I teach lots of things, just adapting my code, so you don't need to write everything. It has buttons, potentiometers, rotary encoders, motorized faders, displays, LEDs, a physical MIDI, Bluetooth. I just added Bluetooth. So we have Bluetooth low energy devices. And then we have the Arduino Programming, which is where I teach how to program, what I'm doing here, but in way more details. And you have the KiCad PCB Design, which I teach how to create printed circuit boards. Okay, you can get the 3 courses together with a discount there, or buy the courses separately. And also there you have the link for the DIY MIDI controller workshop, which is totally free. Okay, guys, I don't know if you're even listening to me anymore, but I would like to thank you for being here. Thank you for your help. You guys even helped me in the code. That was really awesome. I'm gonna try to fix this, and hopefully next time the internet will be better. My last live, the internet was perfect. Everything was perfect, but we never know. Okay. If you're not subscribed, please subscribe, my friend. Please subscribe and give that like. And also, the link to download this code, you can come here. You're gonna have a file project or a file download, and you can put your email, and then it's going to send you this page. And here in the end, you're gonna have this MIDI programming for the Arduino. The code will be there. So it's gonna be, oh, sorry, I don't have it now, but it's gonna be there, like coding from programming from scratch or something like that. You can find it there. Okay, guys, so let me see if I got anything. This will be recorded. The live was not as smooth as expected, but we got into the end. We coded a MIDI controller from start. I think you're in. Yeah, I don't know. It's not doing anything special, my internet, but yeah. But anyways, we did it. I might just do this live again eventually, just to make sure I have a good internet. But what I wanted is just to show you this beautiful world of programming and creative programming, programming for art, for music, for expression. And it's something that really changed my life. I am a musician, but I started as a musician. As always, I graduated in music composition, but once I learned how to program, the way I think, the way I make music, the way I make art changed. And it's really fun. It's a really interesting intellectual process. And it's challenging and it's fun. It's really nice when you get things done. You make your first MIDI controller or even your first LED to blink. And the MIDI controller is just the tip of the iceberg. You can do art installations. You can do all sorts of things with the Arduino. And once you learn in a nice way, in a fun way, which is, for me, is making music, the world opens, you know, for many other things that you couldn't think that was actually possible. And then you start adding customized gear to your concerts, to your composition. And then you start adding interactive lights. And then you just add like lights to your room, like I did here, you know, then you're like making robots. I don't know. You don't need to do that. You can only make a MIDI controller. But yeah, guys, check the links here below. And feel free to send me a message, send me an email. In my website, there's the WhatsApp icon. So you can just go there and talk straight to me on WhatsApp. Okay? So thank you so much, guys and girls. Can't wait to see you building something. So if you build something, please send me or tag me on Instagram. So follow me on Instagram. I think I'm gonna put, I don't know if it's in the description, but I'm going to put. And if you're watching this video now, it's not live, subscribe, that thing. And thank you so much. Abraço. And if you're Brazilian, next Thursday, I'm gonna do a live like that in Portuguese in my Brazilian channel, which is I'm going to do its debut. Okay? So thank you so much. Ciao, ciao.